All right, so for example 3, this time we are given a graph. And by the way, we're continuing on our 6-5 notes here. You can grab those out and turn to example 3. And we have to write equations. Notice it's got an S, so that's plural. We're writing more than one equation. So we're writing equations for the line in point-slope form and in slope-intercept form. We're going to start by doing point-slope form first, and then I'm going to teach you guys how to convert point-slope form into slope-intercept form. So for point-slope form, I have to start with y minus y1 equals m times the quantity x minus x1. So point-slope form tells me I want a point and I want the slope. When you go to pick the point, you'll notice on this graph right here, there are 2 different points listed. You can use either of those points. It does not matter which one you choose to use. I would highly recommend. I personally try to avoid negatives anytime I can. So I'm going to go ahead and use this point here. I'm going to use the point 2, 3. So instead of y minus y1, I'm going to have y minus 3. Remember your y coordinate comes second. Equals, I don't quite yet know my slope, so I'm going to leave that blank. And I'm going to do x minus, and then my x1 value here is 2. Now I'm almost done writing this in point-slope form, but I don't know what my slope is. So I'm actually going to have to zoom in on my graph here. And to find the slope, I want to find the rise over the run. And remember, when you're finding slope, you always want to work from left to right. So we're going to start at this point all the way over here to the left. And I'm noticing that I actually have to go down 1. So since I'm going down, that's going to be a -1 for my rise. So my rise is -1. And I'm going to run over 1, 2, 3 spaces. So my slope for this example here is -1/3. So in place of m, I'm going to write -1/3. This is the first part of my answer, writing it in point-slope form. The second part is going to be converting that into slope-intercept form. So I'm going to go ahead and just copy down my point-slope form. And I want to convert point-slope form into slope-intercept form. So what I'm going to do is right down here at the bottom, I'm going to write slope-intercept form, which is y equals mx plus b. And the reason I'm writing it down at the bottom is because I like to be able to visualize as I'm working, where am I starting and what's my goal? What am I trying to make my equation look like? So if I'm looking at slope-intercept form, I want y equals. I want to get y by itself. So I need to get this y over here on the left-hand side completely alone. Right now I've got this -3 attached to it, so eventually I am going to have to get rid of that. But before I can even do so, over here, I've got this -1/3 being multiplied by the quantity x minus 2, so I actually have to take that -1/3 and distribute it to everything inside of my parentheses. Well, -1/3 times x is just -1/3 x. When I go to multiply this in -1/3 times this is a -2, a negative times a negative produces a positive, so I'm going to write a plus sign. And then if you need to, off to the side, you can multiply 1/3 times 2. 1 times 2 is simply 2/3. So I'm going to write plus 2/3. So I just applied my distributive property, and now I'm going to bring down my y minus 3. Now, in order to get y by itself, because that's my goal, I wanted to say y equals. Now I can get rid of this -3. The opposite of taking away 3 is adding 3. So I can add 3 to cancel, and I get y equals. Now, since I added 3 on the left side, I also have to add 3 on the right side. And you'll notice that I'm lighting that plus 3 up underneath this 2/3 because those are like terms. This -1/3 x, it's not a like term because I've got the variable on it. And then when I add 2/3 plus 3, I just have 3 and 2/3. And that equation now says y equals mx plus b. All right, so on this next page here for number 37, I'm going to have you guys pause the video, and I want you to practice writing the equation first in point slope form, and then convert it to slope intercept form. All right, so the first thing that I'm going to do for this question here is I'm zooming in on my graph, and I'm going to go ahead and label these points. This would be the point 1, -3. And this right here would be the point -4, -5. And in order to write something in point slope form, I have to know the point, I have to know the slope. It says its name, point slope form. I need the point, I need the slope. So I already have some points here. Now I need to find the slope. And slope is rise over run. Remember, we always want to work from left to right. So I'm going to start at this point on the left. I'm going to rise up 1, 2. So my rise is 2. And I'm going to run over 1, 2, 3, 4, 5. So my slope is going to be 2/5. So I'm going to start by putting this in point slope form. Y minus y1 equals m times quantity x minus x1. And just like on that last example, it does not matter which point you use. Doesn't matter at all. I'm going to go ahead and use this point right here, 1, -3. So instead of y minus y1, I'm going to do y minus. Now my y coordinate's -3. I hope at this point you guys can recognize that when you substitute in that -3, it's going to create a +3. Because this negative and this negative create that +3 equals m, my slope is 2/5, times the quantity, x minus 1. So that's step 1, writing it in point slope form. Step 2, we have to take point slope form and convert it into slope intercept, which is y equals mx plus b. So I'm going to write that at the bottom so I know my goal is to eventually get this y by itself. To get y by itself, I'm going to have to take away this 3. But before I can do that, I've got to distribute my 2/3. 2/3 times x is just 2/3 x. And 2/3 times a -1 is just -2/3. Still got my y plus 3. Now to get y by itself, I've got to get rid of this +3. The opposite of adding 3 is taking away 3. So I'm going to subtract 3 to get y equals. Over here, that 2/3 x is going to remain the same. And I'm going to stack that -3 right underneath its like term, that -2/3. So I've got -2/3, and I'm taking away 3. We can do switch on this, and it's -2/3 plus -3 gives me -3 and 2/3. You're just adding all negatives. So there's your equation in slope intercept form. All right, so you guys can see an example 4 here. I made a bit of a mistake. I forgot to erase this when I printed these, so you guys already have this written in. What I'm going to do right now is just go through and explain where I got each of these pieces from. So example 4 wants to know, is the relationship shown by the data linear? If so, model the data with an equation. So in order to determine if my data is linear, I want to find my slope. In order to find slope, I'm going to use my slope formula, which is y2 minus y1 over x2 minus x1. So we've got to go ahead and find our slope here. In your table, you'll notice your x column's on the left, your y column's on the right. You can pick any 2 points that you would like to do this y2 minus y1 over x2 minus x1. You can see from my example, I just picked these first 2 points right here. So what I did was I subtracted 6 minus 4. So I did y2 minus y1. I did 6 minus 4, and I got 2. Over x2 minus x1 would be 3 minus 2. which is 1. And you'll notice my arrows, I have to subtract it in the same direction. So my slope that I'm getting right here is 2 over 1, which we can just simply write as 2. Now, in order to determine if the data truly is linear, it's a good rule of thumb to follow that you should always find the slope twice and make sure that you get the same thing both times. So I'm going to go ahead and I'm going to do that again. Except this time I'm going to use these 2 points right here. So you guys are going to have to add this in because I don't have that work. I did erase that portion of it. So to do y2 minus y1, I'm going to do 4 minus a negative 2. So 4 minus a negative 2 over. Since I started with the 4, I'm going to start with the 2, and I'm going to do 2 minus a negative 1. These minus and negative will become positive. Gotta make sure to line that up on the parentheses to make everybody happy. 4 plus 2 is 6. 2 plus 1 is 3. And 6 divided by 3 is 2. So we've just calculated our slope 2 different times using 2 different sets of points. We got 2 both times. Since we got 2 both times with the same slope both times, our data is linear. So now we want to model this data with an equation. When you go to write your equation, you are given a whole bunch of points here. These are just ordered pairs, x comma y, x comma y, x comma y, x comma y. So you guys have 4 points, and you also have the slope. So when you are given a point and you are given the slope, you're going to go ahead and write that in point slope form. For my example, I chose to use this first point right here. You can use any of those 4 points. So instead of y minus y1, I did y minus 6 equals m is 2 times the quantity x minus x1 was 3. So this is my equation in point slope form. And when you turn to the next page, you guys are going to notice that again, I accidentally made a mistake and I left all the work here. So we're going to go through and I'm going to just explain each of the pieces of work. Because you're going to have to do this on your homework. The question wants to know, is the relationship shown by the data linear? If so, model the data with an equation. So in order to determine if the data is linear, we're going to find the slope, and you're going to want to find the slope 2 times to make sure it's the same both times. So to find your slope, you've got to do y2 minus y1 over x2 minus x1. Looking at my table here, I'm given a bunch of ordered pairs. This basically is just a table showing all my ordered pairs. And so I'm going to start with these first 2 points right here. And I have to do y2 minus y1. So I'm going to do 9 minus a negative 3. 9 minus a negative 3, you can see I already did that giant plus sign. Added them together and I did 12. Now because I started with the 9 and I took away that negative 3, I have to start with the negative 4 and take away the 2. So negative 4 minus 2 is negative 6. 12 divided by negative 6 is negative 2. So right now, using that first set of points, I'm getting a slope of negative 2. I want to test that out at least one more time to make sure that I get negative 2 again to prove that my data is linear. So now I'm going to use these 2 sets of points. For y2 minus y1, I'm going to do negative 3 minus a negative 9. And you can see here I already wrote that giant plus sign. And then for x2 minus x1, I'm going to do 2 minus 5. Negative 3 plus 9 is 6. 2 minus 5 is negative 3. 6 divided by negative 3 is negative 2. So you can see both times that I tested that theory, I got a slope of 2. You're done. You only have to test it 2 times. If you get the same slope both times, then you can assume, is the relationship shown by the data linear? Yes. You can assume the answer is yes. Now we have to model the data with an equation. So when you go to write your equation, you can pick any point. I'm just going to choose this first one here. And for y minus y1, I'm going to do y minus 9 equals m, my slope is negative 2, times the quantity, And then instead of x minus 4, it's going to be x minus a negative 4. So a minus a negative becomes x plus 4.